Asia Book of Records. That is a wonderful opportunity for the speakers, and this will be published in our National Congress, and we are going to celebrate the centenary year in the November month in front of our Indian President. So I welcome you all for this wonderful session. And our Dr. SENTHAMIL Kumar will introduce our today's first speaker. Over to SENTHAMIL Kumar, sir.
Thank you, sir. Good morning, Charge and all other participants. So I am happy to introduce the first speaker, Dr. J. Santosh, who completed his PhD and environment, PG, everything in environmental engineering and biomethination. Especially, he is specialist in biomethination. He has teaching experience of 20 years. He published 11 journal papers in international and national journals, reputed journals. He attended and addressed in 15 conferences. Also, he published 3 textbooks in environmental engineering. Also, he received an excellent award from Institution of Genius India regarding environmental and sustainability activities. So, he is in charge for all the biomethanization and energy CAD sets in our c-Veeramani Institute of Science and Technology. More than that, he is a very long association with our Thanjavur administration regarding the solid waste and liquid waste management through our Clean Thanjavur movement. He is making awareness among the students and public from almost 20-25 years. He is working in the making awareness among the students regarding the solid waste and liquid waste management. So thank you for this opportunity. Thank you. I request Santosh to continue.
Thank you very much, sir. Thank you. Good morning to everyone. Here, related to sustainable development, and sustainability is a key focus everywhere nowadays. So in this regard, I wish to present my talk, Waste to Energy, a key towards sustainable development. In the present day context of environmental pollution, the continuous generation of organic waste and its improper management has been playing a vital role. However, current global municipal solid waste generation levels are approximately 1.3 billion tons per year and are expected to increase nearly 2.2 billion tons per year by 2025. This represents a significant increase in per capita waste generation rate from 1.2 to 1.45 kg per person per day in the coming decade. Okay. Generally, higher the economic development and the rate of urbanization, the greater the amount of solid waste produced. At the same time, the urban residents produce about twice as much waste as their rural counterparts. India is having second largest population in the world after China, with more than 1.27 billion population, contributing 17.6% of world's total population. So due to increase in population, rapid industrialization, uncontrolled urbanization, and improved living standards, this lead to increased rate of per capita waste generation. So according to Central Pollution Control Board, the country is generating nearly 1,43,449 metric tons of municipal solid waste per day. So municipal waste and industrial process waste, scrap materials, off-specification products, slag and tailings from heavy and light manufacturing industries, refineries, may have the comparatively significant impact on environment. In the municipal solid waste stream, waste is broadly classified into organic and inorganic. Waste composition is influenced by many factors such as economic development and cultural norms, geographical location, and climate change also. So high-income countries are implementing the landfilling and thermal treatment of waste. So this is what happening in the Indian conditions. Nowadays, developing countries like India are practicing the disposal of waste in an open dumping. The consequences of disposal are unhygienic condition in the environment, are susceptible to open burning and are exposed to the elements, vectors, and scavengers. The land used for open dumping may be vulnerable to the physical and chemical hazards posed by the waste. Likewise, the dump sites endow the ideal breeding place for mosquitoes and causing severe illness. Rodents, insects, and other vermin also attracted to open dump sites and may pose health risks also. Similarly, runoff from open dump sites causing the chemicals to pass through the ground and contaminate the wells and surface water, and leachate emissions may contaminate the groundwater source also. So hence the dumping yard becomes the area for anaerobic reaction, where it produces the offensive greenhouse gases such as carbon dioxide and methane. So these gases are contributing potentially to global warming and climate change phenomena. Such dumping activity in many coastal towns has led to heavy metals rapidly leaching into the coastal water also. However, most of the techniques are here, like composting, incineration, and pelletization, refuse to derived fuel. Most of the options are here. So based upon the production of organic and inorganic waste in a particular town or city, the suitable option has to be taken into account. So when disposing of garbage that contains harmful chemicals may also give bleach, acid or oil, which is through the disposing containers, and paper, plastics, and other materials that are banned. So whenever you are placing, whether the slide is moving. So burned or banned can contaminate the air when they are burned. And due to this continuous disposal of chemicals may build up the ozone layer and cause toxins like dioxin. These fumes affect the air and also the suffocation to the public. The garbage that is disposed of improperly also begin to release methane gases. This is what I have already told. The dumping yard will be the place for the release of the toxic greenhouse gases, that is methane and carbon dioxide. So this may destroy the Earth's ozone layer and contribute to significant climate changes or global warming. Let us see the overview of different solid waste. So the typical composition of Indian municipal solid waste, we are having biodegradable as 51%, recyclable as 17%, hazardous components as 11%, and inert material as 21%. So, however, we have to concentrate on biodegradable material. At the same time, what are the things we are allowing for recyclable? It should be properly sought out and it should be allowed for recycling purpose. So the Indian scenario, it is mandatory for municipal corporations and urban local bodies to collect 100% waste and to segregate and transport the waste to waste treatment and management facilities. So number of compost plants 279 and biomethination plants 172. So next to biomedical waste, This type of waste is generated during the diagnosis and treatment or operation or animal research activities. The disposal of biomedical waste, however, for 500 tons per day, they are having the operations like they are introducing the waste into the autoclave for sterilizing the bacteria inside the biomedical waste, and incineration, further incineration, kill the bacteria, and also also treat the waste into fine ash powder and release the white fumes through the chimney, and the sharps like needles, syringes will be converted into fine powder through shredder. So these ashes through incinerator and syringes in the form of powder will be disposed safely through a polyethylene sheet in a secured landfill in the treatment agency itself. E-waste. The e-waste or electronic waste means of waste of electrical and electronic equipment. It may be in the part of whole or part or rejected from the manufacturing and repair process, and which are intended to be discarded. And dumping of e-waste nowadays also a major challenge in India. However, this improper disposal of this e-waste not only creates health hazards, it becomes a serious issue and permanent negative impacts to the public. Plastic waste as a result of polymerization process and can be molded into desired shape. This is the phenomenon of plastic manufacturing. So due to continuous population growth, urbanization, and industrialization, the usage of plastics where it is easy to carry and easy to handle, so that most of the public are using the plastics. And 60% of the discarded plastic waste can be go for recycling purpose, and 40% remains uncollected. And thermoplastics, which are allowed for recyclable purpose, thermosetting plastics may not allow for non-recyclable. They are non-recyclable, and some of the microplastics, that is the fine plastic carry bags, which should not be used for burning or dumping, which won't be get degraded immediately, will take more time and will contaminate the soil and the groundwater also. Some plastics like HDPE, that is high density polyethylene, low density polyethylene, and polycarbonate can be leached into food items. Whenever you carry the food items with these bags, and this may leach into the food particles also. And thermosetting plastics such as melamine also emit acids and hydrocarbons into the food items. So if you consume the same thing in means immediately toxic will be there. And thermoplastics are used in making food and beverage packing. They can leach toxic hydrocarbons and heavy metals into edible contents, and may be the key cause for pollution when burnt or incinerated. What are the various technological options? Here, consider a city or town. This is the municipal solid waste collected by the corporation or city. These municipal solid waste may be allowed for incineration purpose, for burning, and some of the materials they will allow for separation. So what are the wet waste? What are the dry waste? What are the recyclable waste? Wet waste can allow for compost and another process, anaerobic digestion. Where space is available a lot, when we can go for composting process, and anaerobic digestion is also a viable option. And recyclables, some of the glasses, metals, we can go for recyclable process. And dry organic waste may be allowed for refuse to derived fuel, that is in the form of pellets. It can be converted into compressed and converted into firing fuel purpose. And dry organics may be allowed for pyrolysis, for the conversion of this dry material into oil fuel material, and also for generating power. This dry organic material go for gasification purpose also. So out of these all options, one of the viable technologies for municipal solid waste management is biomethination technology. It's a kind of anaerobic technology, which refers to the production of combustible gas and a value of added fertilizer by anaerobic fermentation of organic materials with certain controlled conditions of temperature, pH, and carbon to nitrogen ratio, and mixing content and alkalinity, acidity. These parameters has to be maintained properly. So through this, why it is called biomethane means the production of methane out of this digestion of this organic matter. Not only producing the methane, it also produces the fertilizers, which is enriched in nitrogen, phosphorus, and potassium. So benefits of biomethination technology provides a better and cheaper fuel for cooking, lighting, and for power generation. It provides an effective, convenient way for disposal of human excreta and helps in generation of productive employment. Not only utilizing in olden days, the biogas production was started with the utilization of cow dung. Now the technology has revived by utilizing different types of waste as the organic matters are existing there. So this night soil also we can utilize as a material for producing the biogas. So what is the anaerobic digestion process happening here? So we are allowing the complex organic matter inside for digestion purpose. It consists of carbohydrates, proteins, and fats. Hydrolytic bacteria attracts these substances and consume these substances and convert into soluble organic molecules through hydrolysis process. These soluble organic molecules are sugars, amino acids, and fatty acids. And acidogenic bacteria consume these, and it produces volatile fatty acids. And further, it will be converted into acetic acid, hydrogen, and carbon dioxide through acetogenic bacteria. And this formation of hydrogen and carbon dioxide contribute to the methanogenic bacteria, and from the acetic acid, it is allowed for methanogenic process. So methane and carbon dioxide is formed finally. So 65 to 75% of methane will be there, and 55% of carbon dioxide will be expected in the digestion of any organic matter. So what are the materials we can utilize for this anaerobic digestion? Land-based resources such as crop waste, sugarcane trash, weeds, corn and related crops, straw, forest litters, and urban solid waste. These are the waste where we can utilize from the land area. So these are land-based resources. This agricultural waste also produces an enormous quantity of biogas when compared to the kitchen waste and that. Byproducts from agro-based industries like oil cakes, bagasse, rice bran, tobacco waste and seeds, waste from fruits and vegetable processing, pressed mud from sugar factories, tea waste may also produce the biogas in an easier way. So some of the researchers did the experiments with these products, and most of them are not undergone these products and all. Animal-based resources, animal waste, that is animal excreta, cattle shed waste, dung, urine and litter, poultry litter, sheep and goat droppings, slaughterhouse waste in the form of blood and meat, and fishery waste, wool waste, human waste like excreta, urine may be used for this production of biogas. And water-based materials like marine algae, seaweeds and water hyacinth. So we can extract biogas from marine algae and water hyacinth also. However, some of the these materials may have the tight bondage as a lignin and cellulose. That is, lignocellulosic material may be there. So we have to go for some pre-treatment technology before digestion purpose. This water hyacinth is also having the capability of producing more quantity of biogas, but it requires some pre-treatment before allowing into the digestion process. So Here I have shown different types of feedstocks, byproducts from agro-waste, animal-based resources, and water-based materials. But we are utilizing very few material for only producing the biogas. So wherever the pre-treatment is not necessary, in that case only we are going for utilizing these materials. However, if you undergo any pre-treatment technology, then you can utilize more quantity of or different complex materials for producing the biogas in an enormous quantity. So this technology has paved the way for co-digestion process. That means already I have told that you can utilize not only a single material, different types of waste having the different options for producing the biogas. So you can utilize more waste in your digestion process, but it requires some seeding material for converting the all the food materials or any other materials into gaseous matter. So that basic substrate is the seeding material. It may be in the form of cow dung. So, okay, we can utilize in the base material as consists of enormous microbes. At the same time, this food material we can, that is the digestion process. Here we are having the single substrate and another one single substrate. Here I have shown here slaughterhouse waste. So these materials will have different digestion property, and this material also having different digestion property. So you can add these two materials in a single digester to produce the biogas. So this was co-digestion process. In a single reactor, we can utilize more number of substrates to produce the biogas. The technology is called co-digestion process. So, however, they have to mix under homogeneous process. So, pros and cons of this anaerobic digestion technology. So, more number of biogas installations are there available in the country. However, some of the biogas installation are not working properly, and the yield of the biogas may reduce due to some pros and cons. So here the lack of mixing, that is, it may be there will be the formation of scum due to the lighter materials on the top. It won't allow the gas to pass through. So this scum will be formed at the upper layer due to the improper mixing. And also this improper mixing may cause the digestion improperly. Not proper digestion may be happen, and the yield, obviously the yield will be reduced. So lack of feedstock, depending upon only cow dung and depending upon only few substrates only, people are going for biogas process. So that is lack of feedstock also an important parameter. And pre-treatment and enhancement techniques. Pre-treatment. So most of the biogas installations, they are not going for any pre-treatment process. Simply they are adding the cow dung and parallelly adding the waste material. So if the pre-treatment is there, then yield will be more. And enhancement techniques, sometimes there is the requirement of enzymes or any additives in order to increase the yield of the biogas. So we can go for additives to enhance the biogas production. And some of the advantages is where we are adding different types of waste in a single reactor. So dilution of the toxic compounds, say one may be the toxic content in one element may be more and one element may be very less, so that the toxic component will get diluted, and adjustments of the moisture content and pH value also in the same way get adjusted, and supply of the buffer capacity and increase of biodegradable material content. So most of the material will have the nature of biodegradable, and they will immediately degrade and produce the gas. And due to these different types of waste utilization, there will be different range of bacterial strains may be there. Pre-treatment. The pre-treatment associated with anaerobic digestion technology may be physical pre-treatment, chemical treatment, and biological pre-treatment. So in physical pre-treatment, we have to go for solids reduction. That is, the particle has to be converted into fine particles by cutting or milling or shredding like that. And odor removal, inactivation, pathogen reduction, less energy use, and increased energy recovery from the methane. So these are the advantages by using the pre-treatment technology. The physical pre-treatment is ultrasound, mechanical, jet, and high-pressure homogenizer, mechanical ball mill pre-treatment, thermal and ultrasonic pre-treatments may be used for the physical pre-treatment. And chemical pre-treatment, we can include alkali, wet oxidation, ozonolysis pre-treatment, acid hydrolysis pre-treatment. And for biological pre-treatment, we can go for the addition of microbes or bacterial strains in order to improve the or in order to remove the bondage between the lignin and cellulose. Or combined pre-treatment also we can go for by thermochemical or alkali thermo. So here I have shown the potential gas production from different feedstocks like cattle dung, buffalo dung, camel dung. So different dung having the capacity of producing the gas. The gas yield per kg of cubic meter gas, that is the per kg of cattle dung will release 0.036 of cubic meter of gas. So per day it may, for 10 kg, it may give 0.36 cubic meter. So these are the different potential of the biogas production from different feedstocks. Similarly, this biogas having the calorific value 4713, and so by using the standard burner, and we can replace the other fuels by that is the factor is the 1, and the conversion efficiency is about 60%. Effective heat utilization 2828. When comparing to this LPG and coal gas, electricity, so here the calorific value is more. And LPG is, however, the calorific value is more, but we are utilizing the waste for the production of biogas. So one thing, we are reducing the quantity of waste, at the same time we are generating the heat out of it. Properties of different manure and or different waste. So here the 500 kg of animal weight may give the excreta of 15 kg, and which produces 0.25 to 0.42 meter cube per kg of biogas. So it may the presence of total solids and presence of volatile solids, and this volatile solid content is the they are the major role. They play the major role for the production of biogas, and the carbon to nitrogen ratio should be within 30. So here we are having from dairy 19 to 25, and chicken we are having 6, and pig 19 to 21, like that. Factors affecting anaerobic digestion process. So pH, temperature, loading, retention time, mixing, and alkalinity. These are important parameters where we have to maintain these parameters in a digester. Then only the digestion will be in a proper manner. Then only it will release the biogas continuously. Temperature for biogas production, the temperature should be 25 degrees Celsius to 37 degrees Celsius. That is mesophilic temperature. Mesophilic bacteria will act on that. With sudden drop in reaction rate, production of biogas also falls. When temperature fails, immediately there will be the yield of biogas also become less. Thermophilic bacteria may produce the biogas at the temperature of 555 degrees Celsius. The production rate is high when compared to the mesophilic bacteria. So here there may be the chances for rapid fluctuation if 2 to 3 degrees Celsius of decrease in temperature may upset the biogas production. So as per Indian temperature condition, the ideal temperature is the mesophilic temperature. So these secondary effects, solubility of carbon dioxide and heavy metals, and also this thermophilic digestion will generate more hydrogen sulfide gas, and no significant difference in ultimate yield if temperature range lie with 30 to 60 degrees Celsius. Where when it reaches 65 degrees Celsius, the yield of the biogas drops and the digester won't work further. Next one, retention time. It's a theoretical time that a particle or volume of liquid added to a digester would remain in the digester itself. So how long it takes to convert all the solid particles into gaseous matter and residue. So that theoretical time is called retention time. So here the volume of the digester divided by volume of organic matter added per day. Solids retention time. After the production of gas, the average time that the solids remain in the system. So the weight of volatile solids in the system divided by weight per unit time of volatile solids leaving the system. So how much quantity of volatile solids, that is after the production of biogas, how much solids are retained and how much it expelled out. So that is maybe determined by using the solids retention time. How long it is inside the digester and when it starts to expelling. If the retention time is cut into half, the gas production rate will also drop and may leads to the failure condition, and that is entirely the expelling will be more, that is in the form of washout. So the bacterial cultures also decrease and no longer effective for further gas production. So the decomposition or digestion of organic substances under anaerobic condition is slow. Hence, these substrates have to maintain varying length of time for digestion to complete. Organic loading rate. That means how much quantity of organic matter we have to add inside the digester in terms of volatile solids. Volatile solids play the major role for producing the gases. So how much percentage of volatile solids are there, or how much gram of volatile solids per liter of your quantity added inside the digester, you have to determine by organic loading rate measurement. Carbon to nitrogen ratio should be in the range of 20:1 to 30:1. Normally, the optimal ratio is 25:1 for bacterial growth inside the anaerobic digester. Inappropriate ratios, that is, if high ammonia is there or high volatile fatty acids accumulation is there, and it may be due to the varying carbon and nitrogen ratios. This also inhibit the process. Total solids content. It is the amount of fermentable material in unit volume of digester. So how much quantity of solids are there, and that solid content is utilized for digestion purpose under the influence of pH, temperature, and effectiveness of the microorganisms in decomposition. So if based upon the total solids data, we can predict how much yield of methane will be out of from the particular feedstock. Suppose we are using vegetable waste or food waste or human excreta. Out of that, what is the total solids data? We can predict the theoretical yield of methane by using certain empirical formula. Alkalinity and pH. These are the twin parameters. Sufficient alkalinity is essential for proper pH control. So if alkalinity serves as a buffer that prevents the rapid change in pH. So pH always should be maintained in 6.8 and 7.2, where volatile acids are converted into methane and carbon dioxide. So alkalinity should not be increased beyond 7.5. So addition of, in order to maintain the pH value in a proper manner, between 6.8 to 7.2. Addition of sodium hydroxide and calcium hydroxide alternately may adjust the value of pH before digestion process or during the digestion process itself. Rise in pH, that is ammonia nitrogen accumulation, effluent was gradually removed and replaced by fresh substrates. If there is increase in pH, if the pH is increased, then there may be the chances for accumulation of ammonia nitrogen, and that effluent has to be properly removed and the fresh substrates has to be added there. So for maintaining the pH, we can add the ammonia anhydrous, caustic soda, lime hydrated, soda ash, and sodium bicarbonate. Commercially, we always go for this sodium bicarbonate to maintain the alkalinity condition, that is 6.8 to 7.2, to maintain the optimum pH value inside the digestion. So different substrate will have different composition. Based upon the nutritional value, we can the material have the tendency to produce more quantity of biogas. So in order to determine the organic fraction of the organic matter in the substrates, so we have to go for the measurement of volatile solids and measurement of carbon chemical oxygen demand. So 1 gram of chemical oxygen demand gives 0.35 liters of methane. This is the empirical rule. So based upon this, we can determine the theoretical methane production out of the what type of waste you are utilizing for biogas production. We can theoretically determine the quantity of biogas or predict. We can predict. Another one important parameter, what I have told nowadays, most of the biogas installations are getting worse and not performing well due to this improper agitation or not having any agitation at all. So mechanical agitations has to be provided, or any other hydrodynamic agitation or liquid agitation or gas agitation. Among these 4 agitations, any one of the agitations has to be performed in the digester, or otherwise the digester won't work. So mechanical agitation in the form of stirrers, in the form of baffle plates, in the form of surface cum destroyer. So you can utilize these materials, these provisions to release the biogas in a proper manner and to cut off this cum. And hydrodynamic mixing by using the pumps up and down or down up, from bottom to upward or up from top to bottom. Like that, we can allow the slurry content for proper mixing. And liquid agitation. This agitation also, we can agitate the liquid by circulating itself inside the digester, sucking from the bottom and allowing to the digester at the top with the different outlets. So there will be the continuous agitation causes the scum to remove in that area. And gas agitation, whatever we are doing, there is liquid content to agitate. Similarly, what the gas produced inside the digester may be allowed with high pressure into the same liquid in order to agitate the liquid content. So careful monitoring and control of pH and alkalinity may start the digestion process immediately. So for the initial gas production, it requires approximately 1 month to maintain the steady state condition. So the optimum pH range have to maintain inside the digester 6.8 to 7.2, and ammonia nitrogen should not increase 1500 to 3000 milligram per liter. Increase in ammonia nitrogen or alkalinity may lead to the foam production and scum production inside the digester. So this may lead to the upsets and unstable digesters by this hydraulic overload, organic overload. If water content is more, or if organic matter is more, then there may be the chances for these upsets and unstable digesters may be happen. Similarly, pH, if pH is not maintained at 6.8 to 7.2, then there may be the chances for upsetting the digester temperature fluctuations, toxic to large withdrawal of sludge, and sudden changes and presence of oxygen due to any leakage in the digester cover may lead to the upsets and unstable digesters. So these are some of the operational conditions for acceptable activity of methane forming bacteria for producing methane. So hydraulic retention time, here they have given 10 to 15 days and pH 6.8 to 7.2, temperature 30 to 35 for mesophilic bacteria and thermophilic 50 to 56, volatile acids in the form of acetic acid 50 to 500 milligram per liter. So biomethanization in the practice. So far we discussed about the theoretical condition. This practically where we have applied this technology here in our institute. This is the 500 meter cube biomethanization plant. This top portion covered with the tarpaulin hood to collect the biogas. The gas production capacity of the digester is 500 cubic meter per day. Here we are utilizing cattle dung, night soil, vegetable waste and food waste. The volume of gas produced can generate 60 kilowatt of electricity, and it not only produces the electricity, it also produces the byproduct, that is high soil conditioner in the form of fertilizer. The layout of the plant. The central portion is the digester, which is anaerobic condition. It's the cow dung loading unit, and this is the mixing unit where we can mix the cow dung without any inorganic material, and it is diluted and added to the digester here. And food waste and vegetable waste, which is converted into fine powder, pulpy material by using rasper as the unit. Through this rasper unit, all the materials will be converted into fine pulpy matter and is allowed to the cow dung and mixing inlet unit. This both the inlet is the organic inlet unit, where we are adding the food waste and vegetable waste and cow dung along inside the digester itself. And this is exclusively for night soil. It is collected from all the blocks from the campus, and it is stored here and is allowed to the pass inside the digester through this inlet. So we are having two inlets. One is for organic waste, another one is for the night soil. And each and material will have different consistency. It won't get mixed along with each other. So for this purpose, we are having agitation motor. So it will suck the slurry from the bottom and shower from to the top. That is the recirculation. What I have told now, that is agitation purpose. Agitation is here by using agitator motor. It will be sucked from the bottom and it will be allowed to the top through peripheral line. And blower also, we are using this blower pump. This red line is the gas line, where through blower we are sucking the gas or collecting the gas, and it is allowed to pass through scrubber. Scrubber, which removes the carbon dioxide and hydrogen sulfide and allow only the methane. And this methane is allowed to pass through the engine. Engine will be started with diesel, and it will be next the gas will be allowed through the gas mode valve, and power will be generated to the hostels. And it's not only producing the biogas, and also it produces the manure through the sludge drying bed. The residue which is left after the production of gas, which is expelled through the sludge drying bed, which consists of 70% of liquid content and 30% of solid content. After draining, all the solid material will be allowed to the vermicomposting unit in order to enrich the nutrient value of phosphorus, nitrogen, and potassium. So this will be converted into manure, and we are selling this manure to the public. So the water drained after extracting the solids content, this drained water is allowed once again for cow dung mixing and food waste, vegetable waste mixing. So there is no existence of any waste here. So all the wastes are completely utilized. Thank you.
Okay. So, excellent. Myself, Muriasa Pandian, Honorary Secretary, Hosur Local Center. Excellent session. This 500 cubic meter plant capacity size, how much it cost? How much the land area used?
This 500 cubic meter capacity is the gas production capacity of the plant.
Okay.
And the project is about 60 crores, sorry, 60 lakhs. The project cost is 60 lakhs, and we received a subsidy from the Ministry of New and Renewable Energy. And the initial cost only the 60 lakhs, and we continuously we are utilizing the waste material for process.
How much area is required?
It requires about 1,000 square meters, more than 1,000 square meters.
1,000 meters square. In which
diameter of the
which year you constructed?
in year 2010.
Okay. Thank you. Excellent.
This is running, sir.
Sir, what is?
Yes, sir.
Sir, same question, sir.
Yes, sir.
What is the payback period? How much you are getting a subsidy, sir, from government?
Not now, sir. We received the subsidy in the during the commencement of the work, because
Okay.
we spent 60 lakhs. We spent 60 lakhs.
Okay.
The cost of the project is 60 lakhs. One third is received as subsidy from the government. One third, 21 lakhs. So it may be cost more than 10 years.
10 years.
Which year is the payback period? We gone through already 10 years back one.
Okay. Thank you.
We spent actually 1 crore for us the design research project for different specializations can utilize this field. So we spent nearly 1 crore for laying pipes and everything. However, the project cost for the proposal was 60 lakhs only. More than 60 lakhs we have spent. 40 lakhs also additionally we spent. We received the subsidy as 21 lakhs. As we are the nodal agency for setting the biogas plants in Tamil Nadu.
Oh, great.
Thank you, sir. You are also doing consultancy work for others, sir.
We will go for giving technical know-how for a different biogas area installation.
All the institutes should involve this project, sir. So they must, because they have a local hostel facility.
Yes, sir.
Definitely,
They are asking some more agencies. They are asking me for designing and doing consultancy work related to that. We are doing for certain private organizations also. We are doing some colleges.
Thank you, sir.
How much manpower is required to operate this system?
4 or 5 members will be there, and one fitter will be there. Exclusively, one fitter will be there.
Okay, sir, it's nice, very wonderful talk, and the need of the hour to utilizing the free energy, the energy from waste to wealth. Because Ministry of Food Processing also last year they introduced waste to wealth. So it is definitely it will be a wealth to waste will be converted into a wealth form, and bioenergy it's a need of the hour, because electricity powers are going day by day, it's costlier. Because they're changing the rates, everything. So it's a very nice, sir. So I think we can welcome the next speaker, sir. Please introduce the next speaker. Sir.
Okay, sir. Okay, sir.
Is available? Speaker is available, sir. Mr. Ashok Kumar.
Yes, sir. Yes, sir.
Yes, sir. Available. I mean.
Okay. Please.
Okay.
Please go ahead, sir.
I will start. Sir.
Sir, welcome, Kannan sir. Former Secretary, sir.
Actually, Sandar sir will share the PPT, sir, instead of me. This is Dr. Ashok, the present speaker. Sir, can you hear me?
Yes, sir. It is audible only, you can proceed.
Yes, sir.
It's
Actually,
audible,
Sandar sir will share the PPT, sir. Actually, unfortunately, I'm in industrial visit. So I'm in bus right now. Sorry for the little inconvenience. Sandar sir will share the PPT and I will present over from here.
Okay, sir. Okay, sir.
Not an issue, sir. We are here to hear your valuable thoughts and views.
Thank you, sir. Thank you, sir. Actually, thinking that reached the destination within the time, but amid the police got the bus for some fine, so it's delayed. So that's what it's happened to be in the bus itself still.
Not an issue, sir. Thanks for your the communication. Now we have a virtual communication mode that will be very vital also. So nowadays, all people are not interested for the classroom sessions. So all are interested in virtual mode only. So,
we can freely from home listen the all. And we our comfortable zone we can sit and watch.
Shall we start, sir? Shall I start?
Yes, sir. Yes, sir. Please share the.
With immense pleasure, I would like to introduce our professor, Dr. A. Ashok Kumar. He is working as Associate Professor, the Department of Biotechnology, C-Veeramani Institute of Science and Technology. He is having the professional experience of 14 years and as a research supervisor as 2 years, and he delivered the invited talk with 22 lectures and training involved for career quality improvement 25. He is also postdoctoral in environmental engineering in University Malaya Kuala Lumpur, Malaysia, and he has the significant research output and research supervisor in the last 3 years, and he had published the research journals of about nearly 12 journals in reputed international journals, and international conferences also he have published nearly about 15 national and international conferences, and he received a fund for the project, 3 projects, and he was invited for invited talks, guest lectures, keynote speakers, and guest of honor, resource persons in different avenues for conferences, seminars, and lectures. And he was the guest speaker at Intra University also. He organized programs for about 10 programs for during his career, and he received the awards, certificate of appreciation for the admission during the 2020 to 21, best commendable work, and best paper award for international conference. He got BST travel fund for 1 lakh and best faculty from EGS Pillai Engineering College, and he also received several appreciation certificates obtained from organized programs. With these few words, I would like to invite Dr. A. Ashok Kumar, Associate Professor, Department of Biotechnology, to deliver the lecture. Thank you, sir. Please, sir.
Thank you so much, sir. Please share the slide, sir.
Sir.
Actually, please follow my instruction to change the slide, sir. So is it shared or I couldn't view?
Yes, sir. Please. Right.
Or suppose PPT is not sharing, means the PDF you can share, sir.
Okay. Is it okay? Sir, is it okay?
So actually, I couldn't view.
Sir, screen is visible, sir. For us visible.
Okay, then no problem, sir. No problem.
Slide is visible.
You can proceed, sir. Slide is visible.
Okay, sir. Thank you, sir. Thank you
First
for.
slide,
Okay, sir. Thank you so much for the opportunities, and I welcome all the engineers to this wonderful occasion. So actually, every
Santosh, sir,
of
you
engineer.
put full screen mode, sir. Santosh, sir.
Sir?
Full screen.
So suppose PowerPoint means is difficult.
Slide is moving or not, sir? Slide is moving.
No, sir, you have to go for enable editing
screen
first.
mode, I told. Full screen.
Enable editing, then go for a view.
Okay, sir. So keep from first, sir. First slide. Hello, sir.
No.
Santosh, sir.
Sir, wait a minute, sir.
Okay. Or until that, just I.
No, it's okay.
So in Zoom, somewhat it's not coming in a full mode, full.
No, you have to go. You have to show in a view. Go to view, sir. Presentation mode. Not insert, sir.
Okay, thank you, sir. Sir, I'm audible now?
Yeah.
Sir, now it's okay. You proceed, sir. Thank you.
Okay.
Screen is visible.
Okay, sir. Okay, sir. Thank you. Okay, so every engineers has their responsibilities to maintain our environment energy with sufficient way to replace every species in this world. Okay, so the humans want to be live with live without any disturbances. At the same time, in free want to live in free in the earth. Then they need the support of the other species also in terms of the biodiversity as well as the chain management, the food chain management. Okay, so for that, like other engineers, the biotechnology has the more role in development of the sustainable. So in this regard, so hope we know that what is the sustainable development. The development means it's meets the requirement of the current scenario. That in the sustainable means, meanwhile, it should not affect the our future generation, which has the what are the requirement we had, the same requirement the future generation also will need. So for that, the natural resources should not be depleted. So like that, we have to develop our conditions or our technologies in that renewable way. That is, the resources should be regenerative. Okay, if you develop every product in that way, we can meet the sustainable development. For example, there are 14 conditions need for the sustainable development. That means we have to work on that the 14 points. So to meet the sustainable development, for example, first we get to work on the poverty. If we work on the poverty, then we have to make the zero hunger, means no hungry world. Then we have to look up on the good health and well-being. So when we attain these three, then automatically we'll move on the quality education. So when we have this quality education, then we look over our social concern, like first our better part of the gender equality. Okay. So when it is all obtained, then we look over the our concern of or our access of the clean water and the sanitation. Okay. So when we once if you obtain this all kind of the level, then we go for the affordable of the clean energy. Okay. Because when we are obtaining these all technologies from the fossil fuels, then we move on to the environment concern, the work over the clean energy. Okay. So once we obtain this all, then we look for the decent work at the same time, economically the strong growth. So this all happened through the industry innovation and the infrastructure. Once it's happened well, then automatically the social concern again will come to sort out the problem in the inequalities. Okay. So when it's happened, then we maintain a sustainable city, that means the urban development under the respected responsibility, responsible communities. Okay. So this all happens, then we go for our look over the climates, the world concern, the universe concern. So when the people have this kind of the development or the upliftment, so that is called a developed nation. Okay, a developed nation required this sustainable with these 14 points. Okay, in general, we can say sustainable means which has concern of the environment, then energy, economy, and equality, and socially well-being. So this is base root of the developed nation or the civilized society. Okay, so wherever here we are taking or we are facing the problem, then we are going into the level of that developing country or the underdeveloped country in that form. Okay, so this is the 14 points we got to look over. So for that, the biotechnology has a role. Okay, like other engineers, the biotechnology has a role where the biotechnology can reduces the impact of the all harmful products developed from other resources can be give the alternate way. Okay, the biotechnology is the base thing which has the resources of providing the all products in alternative way, which is a very less impact or there is no harm. So for example, just small example, we are using detergent in industry as well as in our home purpose. We are using detergent and other bleaching agents from chemically derived. So that is a very highly impact over the environment today's. Okay, suppose if you have a alternate through this biotechnology, which is a biodetergent, which is produced from the with the our room temperature itself, no need of higher energy. So we can save the energy. At the same time, it is easily degradable, so it will not harm to the environment. So this is the one simple example of the product derived from the biotechnology, which can at least 50% of the problems can be get down. Okay, so actually the dyes, the industrial dyes, and these detergents, these are the main part of the pollutions sources of the industry. So the detergent now, the actually the Switzerland, Netherlands, Germany, Israel, and this side somewhat the New Zealand. So not a high impact. So these countries, especially exclusively Switzerland, Netherlands, Germany, are need to work on developing of the alternative resources from the biotechnology for whatever the products available from the world. Actually, first I want to tell about what is the biotechnology. So biotechnology is the technique where we're using a life system or life organisms to create or modify to produce some useful product. So that's help in the this can be collaborated with the all kind of engineers. Okay. So the main part of the biotechnology work is we have to select a particular organism. That organism has to be developed in multiple level. That has to be take over to develop a required product in a pilot scale level. Then we get to scale up and take into a bulk production. Okay. So the present slide, which is shows the history of how the biologist became a derived a bioprocess engineer, and latest the biotechnologist. The BTech biotechnology, which is started in 2002 from India, and around the 90s, 95 in other developed countries like US and Europe. It has some long history. When actually the Alexander Fleming in photo, which is showing this Alexander Fleming, who invented this penicillin. The penicillin is a important antibiotic, which was invented during 1930s years. That time, what happened? The penicillin was invented by Alexander Fleming. It is unexpectedly it's found. Actually, he was worked for some other development, like other product development or other bacterial development. In that time, there's some of the harmful bacteria are can't develop some particular locations. So where he checked that mold, so it was available with the penicillin. So the penicillin is safe from the this kind of bacteria. Then he made it as a penicillin. Okay. So that was an antibiotic during that time. However, the biologist can produce only from small in milligrams. But during the World War II, we know that the scenario is more number of the tons of we need a tons of penicillin. Okay, or in several kilos of penicillin, several liters of penicillin we need. But the what is invented in the laboratory, they have the only the facility to produce in the very grams, in the grams only. Okay, so any number of we call it is plates. So from one plate we can take from some milligram of only product. But we need, for example, we can relate with our corona lockdown period. So during the corona lockdown period, we need this Covaxin or Covishield in liters. So that much of bulk we need. So if we want to produce that, then we need the engineer support from the chemical engineers to the biotechnologists and the biologists. All support needed. The same thing happened in during the World War II. So the commander, those time the America was not involved in the war initially. So that time the seeking the help from Europe, the seeking help from the America, US. So what happened? They take one idea. They club the two people, the biologist and the chemical engineers. So the biologists and the chemical engineers joined together. So they made a one industrial fermenter. Okay, once the industrial fermenters was developed, so after that, the term called bioengineers was the bioprocess engineer. The term was derived in that time. So the pharmacy. So the pharmacist now the pharmacy industry is mostly worked with this two. So now we are in next level. So we need exclusive persons for this area in food process, agriculture process, and pharmacy, healthcare, cosmetics in all area. So to work with the bioproducts. So here, so what we developed a new domain, bioengineer, which we may call it is a biotechnologist. Actually, the science is the properties of the basic like heat or air, whatever is available, life science, like life sciences, we can say the properties of bacteria, yeast, or microorganisms, we can say. Okay. So once who first develop the application area from this basic science, they may called engineer. So once the application area is developed, the enhancement for those who take say technologist. So mostly we have developed our mostly we have developed our most of the basic properties, science property area, engineers. So we called now it a technologist. Okay. So this happened now. The biotechnologist, engineer people exclusively required for this product development from the biotechnology. Okay. So that is generally the biotechnology, some of the applications of biotechnology can classify into genetic and non-genetic. Okay. So genetic means actually whatever the product we are making from the genetically modified, like we know that our this tissue culture, then we can grow, for example, we can grow a tissue of beef or chicken or any one. Suppose we can reduce the improve what is this pollution of the slaughterhouse. So directly nowadays they're using for in burgers and others, other kind of the industries utilizing. So that's we call genetically modified. Non-genetic means once we use this fermenter, the microbial system, so that's called non-genetic. Okay, so like that we have the various product from biotechnology, like artificial blood vessels, detergents, cosmetics, the preservatives, textiles, which we develop the antimicrobial fabrics, and the aviation biofuels. This all comes under the some of the main applications of the biotechnology, where we need the exclusive biotechnologist here. So now, so next slide, please, sir. Santosh sir. Santosh sir. Okay, thank you. So here, the role of biotechnologist is the sustainable development. Some of the main requirement of the biotechnologist in the sustainable development are shown here. The first one is the bioplastics. So we know well how the petroleum developed derived the polythene plastics are making it harmful to the environment, and what is the impact really we are facing now. So we can understand well. So now the biotechnology is involved. Actually, what I'm telling is the Netherlands, Switzerland, and England, especially the Germany and Israel. So they are from support from the US. That means the fund support from the US. They are having now developing in these technologies of bioplastics. Soon it will come with the with the commercial level. Okay, which is the resources of the polymers, biopolymers derived into the bioplastics. They have the same category of properties having in the petroleum derived polymers. So if you come for the construction biotechnology, okay, last time this our Institute of Engineers lecture I have provided exclusively for this construction biotechnology. The materials can be derived from this bacteria or the microbes, any other microbes, to construct the construction materials like brick and other cements. These are all we can or sand. So these are all we can derive from the mining places. The mining places, what we can say the sands. So from that, the enzymes developed from these bacteria can be organized. This organized means in terms of the club the sand into the single rigid solid without heavy weight. Okay, so this will help us to a strong material without weight. At the same time, it gives the property of the same brick what it's given. Okay, so we can save the environment. Next, if you come for this enzymatic detergent. So when you come for the enzymatic detergents, so I already explained about that the 50% of the industrial pollution is happened because of the bleaching and the dyes. So that enzymatic production detergents can work with the same level of applications, the same level of the impact. However, okay, at the same time, it can be vanished without any impact to the environment. Okay, if we come for the biofuels, instead of the fossil fuels, so it is a depletion. The fossil fuels will depleted. To sustainable development, the resources we can use bio resources to develop biofuels, which can be a good alternate during the period during the session of our generations, our future generations. Okay, so similarly, we can understand well about the biofertilizers. So nowadays, widely they using the biofertilizers and liquid biofertilizers, everything they developed. Now they're developing the biofertilizers from the fermenter system, which the concentrated one can develop into any liter of or any tons of fertilizers from the small amount of the basic small amount of basic concentrated material. So which can be used. Actually, the biopesticides, now the normal chemical pesticides gives the cancer. Even in Tanjore region, the more cancer is causes due to these the pesticides where they're using by hanging over the behind them to spray the pesticide over the field. Just a minute, sir. Okay, I'm in line only. Actually, the pesticides causes the cancer. So when we are using these biopesticides, actually it is the impact over only the pesticide. It's not harmful to the human. Okay, so these are all derived through the bacteria, enzymes, yeast. Okay, similarly the cosmetics. The cosmetics, we know that the cosmetics are very high, which is based high cost, which is based on the biomaterials. For example, if we say lipstick. The lipstick is which is developed from the honey bee wax. That is highly cost. The same times this nowadays the honey is derived from the fermenter in Israel. Okay, so that's wax. Ultimately the wax created from this fermenter that can be bulk is available now to develop a cosmetics. So if chemically produced cosmetics is harm to our skins and others impact. At the same time, it's polluting the industries is polluting a lot of all the what is the land pollution, water pollution, as well as the air pollution. So now this biocosmetics helps to get rid of the such a kind of the pollutions. At the same time, this clothing, the clothing which is a mix of the antimicrobial, this antimicrobial as well as the biopolymers. The polymers which gives the impact of the cotton, which is derived from the enzymes and the biopolymers, bioresources. So which also converted into the same impact of the cotton. Nowadays is all successful in the laboratory level. So now the people working, especially the people from Germany, Switzerland, Netherlands, and the Israel are working in this area. Almost the close. So what is the drawback of this bioproduct means? We are getting a very, for example, biofuel means the calorie is very less. Okay, for example, biomethination. If you say biomethination, where this ethane, where this our normal LPGs is gives the 1,200 joule of calorie, this biomethination gives only 300 to 400 calorie only. Okay, here we have to work out to meet with the calorie equal to 1,000 or 1,200. So for that, there is a research gap. So that's what now Europe countries and US, Israel, and other South East Asia is having more opportunities for the biotechnologists. So this is the reason, because they are spending the more money to fill out these research gaps. So the main one on this bioplastics, construction biotechnology, enzymatic detergents, biofuels, biofertilizers, biopesticides, cosmetics, and clothing. So these are the very wide area where the people are working to meet out with the current requirement. So the research gap is there. So they have the good opportunities. Sir, please go to the next slide, sir. Santosh, sir. Okay. So there is okay. Now we are telling the overall impact, overall the requirement. Okay, easily we can say, but how to work with these to meet out these conditions in industry. So there we call it a green chemistry. The green chemistry is one of the phenomena which works to meet out the shortages of, for example, I told you that LPG have the 1200 gallery, and this biomethanation have the only 400. To meet out the make a biomethanation into a 1200 calorie. There is, we need a workout with the process. So the process on this it's based on the chemistry reactions. Okay, so it may be a chemical reactions or bioreactions. So however, we can meet out from the basic production level. So for that we have some phenomena, green chemistry, which is now followed by the all industries in worldwide. Even the Pfizer is a very important company which is using this green chemistry is a role of phenomena in their industry. Okay, so there is some 12 phenomena category principles are there in green chemistry. The first one is based on prevention, and second one we have to work with the atom economy. That means we have to work in the atom level. For example, the biomethanation cannot be converted into a high joule of energy equal to the LPG means there is a atom level of, or the cell level of atoms present in the cell. That level of conversion is happening in that level only. So we have to work out how to work in the atom level to induce the cells to reach out in that level of the LPG. Okay. So on the other hand, just a small information, the LPG also, we can say it is a bioprocess, but the bioprocess is taken to the long period of time, several years, several thousands of years, we can say. So, but what we are working in the biotechnology, the present scenario means we have to make that several years, what we reached from the several years, how to make it from a one day process. So that is the research gap in the biotechnology. Okay, next is the hazardless synthesis, then safe design of chemicals, safe solvents, and auxiliaries. So what I explained that biodetergents. So there we are using here such detergents, then here we are using such solvents and auxiliaries, efficient energy design, use of the renewable feedstocks, and reduce the derivatives. So I will explain one by one in the principle. Green catalysis, so design for the degradation, because what is the main problem in environment? Whatever we are utilizing, that is not degrading. If degrading easily means we no need to bother. Okay, so we have to make a system which is easily degraded after our uses. Okay, so real-time analysis for the pollution prevention and safety chemistry for action prevention. So now whatever product I'm telling derived from the biotechnology, want to derive from the biotechnology, that production process have to be follow these 12 principles. So the principle one is the better to prevent waste than to treat or clean up waste after it is formed. That means we have to develop our process to prevent the waste. Okay, that means if a process is happening, for example, if you take a reaction and we are getting some product. Okay, for example, if you want to want a curd, if you want a curd means then we add one bacteria bacillus based in the milk. Okay, in the milk we are adding. If the entire product is converted into a milk curd, then that is a bioproduct with the effective. Okay, so that is there is no waste from milk converting into the curd. So that is a good example. So if suppose if I developing a biodetergent, so the biodetergent, the process after the process, the complete the raw material have to be converted into that biodetergent. Okay, so that is a very important here. So that is the principle one. So whatever the process, sir, any disturbance?
No, sir. Please proceed.
No,
Okay,
sir. Proceed, sir.
okay. Whatever the process we are doing, that complete raw material have to be converted into a complete product without any byproduct or unwanted product. So it is a very possible in the biotechnology. So that is I said the example how the milk converted into a curd. So like that we have to make a process. So next, when we come for the principle two, the synthetic method should be designed to maximize the incorporation of all materials with the final product. So this also what is the continuation of the principle one. That means whatever the raw materials we are taking, that entire that process, what we design, the designed process has to be converted to the entire system, entire raw materials into the final product. Okay, if come for the principle three, we have to search into principle three. So wherever the practicable synthetic methodologies is there, we have to design to generate the substance which will not produce any toxicity or which is causes the impact to the human health or environment. So such a kind of the design also we have to take into concern. Okay. So first every raw material has to be converted into a product. So that is the two principles. And next we have to design without produce of any toxicity from the process. And next principle four. So the chemical product should be designed, or any product preserve efficacy of function while reducing toxicity. Means we have to this also continue of the 3 to 4. The chemical product should be designed to preserve. That means the products which product is derived from the reactions that has to be have the potential of reduces the toxicity. So the toxicity will not derive from the reaction. Next, principle 5. So whatever the solvents we are using, that solvents should be environmental friendly. So we get to produce a solvent from the bioresources which we are using for the as a agent for the solvent extraction there, solvent reactions there. So in the industry, the solvent is very wide. Any industry, that may be electronic industries or civil industries, mechanical industries, whatever the industries, the solvents are very general. Detergents are very general. So this has to the possibilities we have to incorporate in the process. And when we come for the principle 6, we have to use the energy, low energy requirement. For example, I told you that enzyme detergent or enzyme solvents can operate in the room temperature itself. No need of giving a high temperature for the process. Okay, so such economically also should take into the concern. So that has to be in terms of the low temperature and the low pressure process we have to choose. When we come for this principle 7, the raw material or the feedstock, it has to be renewable. Again, we have to reuse. Okay, such things we have to incorporate in the green process. Green, we can call, instead of green chemistry, we can call it green process. So principle 8. So we are whatever we have this the unnecessary derivation. We have to stop from the unnecessary derivation of any other byproducts when we are working with the energy, low energy. When we are working with the low energy, because when we are working with the high pressure and temperature, we can stop from the other derivations. But when you work with the room temperatures, so there are possible to whatever the side process take off into the same level. So in that part we have to work in the design process. So when we come for this principle 9, again the catalytic reagents which has to be stoichiometrically strong one, it has to be used again and again. It should not become a say waste. Okay, the catalyst means it is a agent reagent. It will be enhance the process. Okay, it enhances the process. At the same time, it has to use again and again. Suppose once it is the power gone, if you throw it out to the outside, if it is a bio material, then it's okay. Again, it's can't be regenerative means again it became a waste. So in that part we get to work in the principle 9. So when we come for this principle 10, just scanning over here. Principle 10, the chemical products or any products should be designed in the function of environment persist. So whatever we are following so far here, which is easily degradable, one we get to do it. We can to take care. For example, if you make it everything is easily degradable, sometimes what happen, it will be reverse. We cannot use within the time. Within that, very fast it will be become a wasted. So what we have to make it, the principle 10 is saying that some particular environmental impact is given, then it has to be induced to take into a degraded mode. So otherwise it has to be, it should be same category of the equal property of what is the existing one. At the same time, it should not have the environment impact. So when we come for the principle 11, so the further the real-time process monitoring and control of the hazardous substances. So these are all has to be considered into the methodologies of this process. So we get a prior analysis. So prior analysis, because the analysis should not take into after the product produced. So we get to take into a prior when we are starting the process. So this 12 principle is for before you are going to do derive a design design a process. In that time we have to consider to develop a process. This is for the process design. Okay. So the this methodology has to be considered in a starting time, not after. In traditionally what we do, we analyze this all impact after the process formation. But now, so that's what we have now, computation methods. A lot of computation methods we have now to study the data science. Now the artificial intelligence, these are all working on this area only. Okay, this principle 11 and in all principle 2, we can implement this or employ the artificial intelligence, then the data science, data analysis. This all we can implement very strong. So we have a wide opportunities also in that part. Again, in now India also, this the Department of Biotechnology of Government of India has formed a vision and mission of mission and mission of 2021 to 2025 to derive a 150 billion economy from the biotechnology through the implementation of these bio industries in the B and C towns, okay, or B and C cities. Okay, so that's 21 to 25. Now it's on the process. So based on that only, we have now formed this this bio IT. These are all happening in this 2021 to 2025 vision and mission of the Department of Biotechnology of Government of India only. Now we are having a different implementations is going on. Okay. So in India also now they're taking a concern of the sustainable development, taking as a main part of the biotechnology, where we are the manpower supply to this Europe and the Israel. Either the manpower supply to the Dubai or Middle East, or the manpower supply to these elect of Europe and Israel and USA. So we are the man supplier. Okay, so they have the wide opportunities in this area of from bioplastics to the cloth, Apart from that, a lot of the cultivated meat. Then now the McDonald's are started to using this cultivated meat. Cultivated the meat in the just using cells. The cultivated the meat in the laboratory, sterilized conditions. So we are free from the antibiotics. Okay, so the cultivated meat we can get. So just to derive the presentation from this other presenters, just I organized the presentation in my part. Okay, just I clubbed into biotechnology and this green chemistry. Okay, thank you, sir. Thank you so much. If any query, I'm ready to clear. Thank you once again. I thank you all the Institute of Engineers at Tanjavur and Dr. Santosh Kumar sir for these opportunities.
Thank you, sir. Thanks for your great lecture. I think our engineering friends are very much useful to hear these two lectures. I thank you to participate, Dr. Sir, Engineer Saleh Manalan sir, and Engineer Murugesh Pandian sir, and then Karupusamy sir, to spend your valuable time spending with us to hear this wonderful lectures. And today the morning session will be wind up, and then we'll see in the afternoon. 2 o'clock, the afternoon session will start. Thank you.
Thank you. Yeah.
Thank you, sir. Thank you.